On number 26, we're to solve the equation by the method of our choice, and then support our solution by using a second method. So we're going to solve this two ways to confirm our answer instead of checking it. So the first way I like to use is to convert the equation into an exponential equation. And since our base is 10, I'm going to write 10 to the right side, which is 6 in this case, is equal to x squared. Well, then I want x by itself, so I'm going to raise x squared to the 1/2 power. And when I do that, I get x equals 1,000. And that is, in fact, the answer. Well, now let's look at another way to think about this. If I don't want to convert it into an exponential, the only other option is to get matching bases on both sides, or matching log expressions, so that I can use my one-to-one property. So I have log of x squared equals 6. Well, I want to rewrite the right side so that it is also a log 10 expression. So if I want to write that as a log 10 expression, what gives me 6 is log base 10 to the 6th. So then, because of that, I can set x squared equal to 10 to the 6th, raise x to the 1/2 power, and I get x equals 1,000. On number 30, we have a pretty ugly equation here to solve, and this is probably the most difficult of the problems on your assignment and the most difficult one of our examples here. So let's get started. Here we don't have a logarithmic equation, we have an exponential equation, but it has two exponential expressions in it that cannot be combined because they have different exponents. So the first step would be to isolate the sum or difference that you find of these two terms, which in this case we would accomplish by multiplying both sides by 2. So that gives us 2 to the x, let me write that a little smaller because we have a lot to write here, 2 to the x plus 2 to the negative x equals 6. Well then, it's not really obvious, but in essence this is 2 to the x plus 1 over 2 to the x equals 6, so this might make it in this form more obvious why we're going to do what we do next, and that is to distribute or multiply both sides by 2 to the x to get rid of the 2 to the x in the bottom of this expression, or this term. So when I do that, I have 2 to the x times 2 to the x, which would be 2 to the x squared, and then I have 1 when I distribute 2 to the x over 1, times 1 over 2 to the x, which is going to give me 1. And then I have 6 times 2 to the x. Well, this just looks like it's getting us nowhere, but we're going to move all the terms to one side, and we get 2 to the x squared. That is a square. Let's fix that. One more try. 2 to the x squared minus 6 times 2 to the x plus 1 equals 0. Well, what we have here now is a quadratic term, and we can see the quadratic nature of it if we begin by letting n equal, and again I'm going to try to write smaller so I can get all this in this one screen, let n equal 2 to the x. Then we can rewrite our equation as n squared minus 6n plus 1 equals 0. Well, that clearly won't factor, so we're going to use the quadratic formula, which is negative b, which would be positive 6, plus or minus the square root of b squared, which is 36, minus 4, times a, which is 1, times c, which is 1, over 2a, but since a is 1, that's just 2 on the bottom. Then we just clean that answer up, and we get 6 plus or minus, and I'll go ahead and put the 2 on the bottom, and then when we multiply 4 times 1 times 1, we get 4, so that's the square root of 32, which then can be simplified to 2 plus or minus 4 on the square root of 2 over 2, and then we distribute the 2 in the bottom, and we get 3 plus or minus 2 on the square root of 2. Well, that's our two answer candidates. And the reason those are only candidates is that we have to remember where this n comes from. N has to be 2 to the x, and we know that 2 to the x is greater than 0, so the only one of our answers that makes sense from the 2 that we got from the quadratic formula is the positive case of 3 plus 2 on the square root of 2. So since that's what we know has to work, then we set up an equation based on the relationship we established by bringing the n into our analysis, and we set 2 to the x equals 3 plus 2 on the square root of 2. And then here you're motivated to use a particular base if you want to get the x out of the exponent, which we do, because that's our job here, is to solve for x. So we're going to take the log base 2 of both sides. So when we do that, we have the log base 2 cancels and leaves us x on the left equals log base 2 of 3 plus 2 on the square root of 2. And then if you type that into your calculator, you will get a decimal approximation of 2.54311. And that's the answer. Now, the directions here also say solve this another way. I think one time is enough on that equation, so we'll let that go as sufficient work. And that's the end of this video.